Hello everyone, today we're going over 2.6 transformations of functions. Last time, I gave some review how we can graph the basic functions. I show you how we can graph the linear function f of x equal x. And also I show you how we can graph the function. I mean this is all of them review because we plot all of them by using the tables. The function also I review how we can graph the function f of x equal x squared, and also f of x equal x cube, and also the roots function like the square root of x and the third root of x. Also, I show you how I give you a review for how we can graph the function f of x equal the absolute value of x, and the function f of x equal 1 over x and 1 over x squared. And I give you the definition here for the vertical and horizontal shifting. I said, this is like review here. I said if c is a positive number, so the graph of the function y equal f of x plus c, we shift the original function f of x equal f of x upward c units. C units is depending in the number here. If it's 5, we shift it upward, the function, the original function upward 5 units. If c, this is negative number, for example, -2, we shift the function f of x equal the y equal f of x downward c unit, depending in the c. If it's positive, we shift it upward up. If it's negative, we shift it down. But if c is inside the parentheses, inside the function, we're going to shift the graph, the origin function y equal f of x to the left c units. And if it's negative and inside the parentheses, we're going to shift the original function y equal f of x to the right c units. So if we have here negative, we have to shift it to the right. If it's positive, we have to shift it to the left. If here we have negative outside, so we have to shift the original function y equal f of x downward c units, so down. If it's positive, we have to shift the original function to the up. Now I'm going to give you example for this. So my question is graph example. So by using the function, or by using the graph of the function f of x equal x squared, by using the, like I give you the original function here, the original function is f of x equal x squared. And now the question is graph each of the following. So number one, g of x equal x squared, g of x equal x squared plus 2. Number two, graph s of x equal x squared minus 1. Third one is 3, d of x equal open parentheses x plus 2 square. And the fourth one is L of x, or I'm going to use the s of x. Now I have s h of x equal x minus 3 square. So here we have the square root. This is f of x equal x squared. Here we have g of x equal x squared plus 2. here x square minus 1, here x plus 2 square, and here x minus 3 square. Okay. Now, who will told me the first one, which rule we should use to graph the first one from 1 to 4? Here we have 1, 2, 3, 4. Which rule from 1 to 4 is representing to graph the first one, g of x? Or
The
how
first
we
one?
can, the first one, yes. Okay, how we can, now my question, how we can graph g of x, this one, x squared plus 2, depending on the original function f of x equal x squared. Any idea how I can graph the g of x? So for the first one, they said the graph of y equal f of x plus c, we have to shift the graph of mean like original function. The original function here in my example is f of x equal x squared. We have to shift the original function upward c units. So Aziza said you can move the graph up 2 units. Which graph we should to move it up 2 units?
F of x equals x squared.
Exactly. So we have to, like, starting my question to graph the something of this, we have to graph the original function is f of x equal x squared. Then we have to shift it upward c unit. I mean, we have to shift it 2 units upward. So let me start doing the first one. So here is my my y-axis, and this is my x-axis. And first of all, we should to graph the original function. My original function is f of x equal x squared. So the graph for this, as we learned last time, is look like parabola. It's look like a cup like this. This is the graph of my function f of x equal x squared. Okay. So first of all, we have to graph the original function. My original function is f of x equal x squared. Now we have to graph the function, g of x equal x squared plus 2. This is mean we have to graph the original function, then we have to shift it 2 units. If I want to rewrite this function to explain it more and to like make it exactly look like this, I can write this one as g of x equal, instead of x squared here, I can represent it as f of x, because f of x equal x squared. So I can substitute instead of x squared the function f of x. So this is f of x plus 2. Now, if you go back to the rules, it's look like exactly the rules. The graph of y, instead of y, I use g of x equal f of x. This is my f of x plus 2. My c is 2. We have to shift the graph of y equal f of x, means we have to shift the graph, the original function. This is mean we have to graph the original function f of x equal x squared. Then we have to shift this one upwards 2 units. The c here is 2. We have to shift this function, the square of the x squared, 2 units up. Now let me graph the function g of x. So upward 2 units. This is the first unit. This is the second unit. Here is 0. This is 0, 1, 2. So the head, the vertex is here. Now the graph of the g of x is supposed to be something like this. And this is my graph of the function g of x. This is g of x. You have to when you graph the function, you have to named or give the name behind the function. So this is g of x. The black one is you have to write the function f of x equal x squared. Here you have to write g of x to show me you understand what you did. g of x, and also you have to show me this point is 2. This point is 2. This is mean you shift the original one from the 0, 1, 2 units, and all points are shifted 2 units up. So all the point is shifted 2 units up. Any question for this one? Any question? Yeah, this is translation. This is the translation. This is the first kind of translation is shifting up. This is the first kind of translation is vertical shifting. We shift the function upward 2 units. We move all the points 2 units upward. Now for the second one, who will give me the idea for how we can graph the second one? Or who can rewrite this one and explain after like the first one and explain how we can shift and what is the original function and how we can shift it? Yes, go ahead, Anta.
So we can write s of x equals
Equal what?
f of x minus 1.
Exactly. This is equal f of x minus 1. Now, how we can graph this one?
You can plot the point at -1 on the
We have,
y axis, -1, and then the graph is gonna go downward.
okay,
All the
perfect. So
points.
this, yeah, thank you. This is exactly look like number 2, the graph of y equal f of x minus c. Here my c is 1. To graph the function f of x, y equal f of x minus c, the c here is 1. We have to shift the original function f of x equal x squared downward 1 unit. C is 1 unit. So the point here is 0, 0. So 1 unit to the down supposed to be here. This is 1 minus 1, I mean. Now all the points should be moved, should be shift to the down as 1 unit. So the graph for the function supposed to be like this. All the points shift 1 unit down. So this is the graph of the function s of x. Shift down for the black one. We shift the black 1 unit down. Okay, any question for the second one? And you have to label the name of the function is s of x. Second one. Now for the third one, how we can graph the third one, d of x equal x plus 2, everything square. Yes, Anta. For the third one, how we can graph the third one, d of x equal x plus 2, everything square.
I believe we were to simplify it, that would be x to the power of 2 plus 4. So
X,
basically that would be us moving it to the like where the y-axis is up
so this
4.
is this one equal is x plus 2 square equal x square plus 4. Is this correct? Does this correct? Is x plus 2 square equal x square plus 4?
No, it's not.
No, this is not correct. How we can make it correct? This is not correct. The correct things here, yes. Who will tell me what is the correct things here?
It would be x squared plus 4x plus 4.
Exactly. Plus 4x plus 4. This is the correct. This is not correct. This is not equal x squared plus 4. Okay. This is not important how we can do completing the square. Here we have to use the rules from 1, 2, 3, 4. Okay. So to use the rules from 1, 2, 3, 4, we're not going to extend it, expanding this one. Here we're going to choose, or we have to change the function here to make it one of the rules from 1 to 4, and then we have to graph it. So I know my function f of x equal x squared. Now I can modify of this function to make it something equal to this. Okay, let me do it in the next slide. So number 4, d of x equal x plus 2 square, x plus 2 square, and my function is, the original function is f of x equal x square. Now I have to plug something inside the original function. This is my original function. This is my function, original function of x equal x square. I have to plug something inside this function to make it exactly the same of the function d of x equal x plus 2. So what I should to plug here instead of x to make this function f of x, to make it exactly similar to the d of x? If I plug inside x here instead of x as x plus 2, if I put this value inside x instead of x, so I'm gonna get something like this, f of x, because this is actually is x to the power 2. X squared is the same as open parentheses of x to the power 2. Now here I'm going to plug x plus 2 inside the function. So f of x plus 2, this is equal here x plus 2 everything square. Now look, f of x plus 2 equal to the x plus 2 square, and this is equal to d of x, because d of x equal x plus 2 square. So x plus 2 square equal d of x. So actually to graph the function d of x, so actual d of x, this one, equal f of x plus 2. Now to graph the function d of x, we should to graph the original function f of x. Then we have to use the rules. The rules here said, if to graph the y equal, y here is d of x equal f of x plus c, we have to shift the original function y equal f of x to the left c unit. Y to the left because we have plus. Plus c means we have to shift the function, the original one, left c unit. Same things here. The 2, if we're looking back, number 2 is inside the function, inside the parentheses. Here d of x is not the same as before f of x plus 2. The 2 is inside the parentheses, but here the 2 outside. This is up and down, and this is left and right. Why left and right? Because the 2 inside the parentheses, but the 2 here is outside the parentheses, so up and down. We have to graph the original function, and then we have to shift it up and down. It depends in the c. Here we have positive 2. This is mean up. Here we have positive 2. This is mean left. So to graph this function d of x, we have to graph the original function. This is my original function. The original function is parabola. It's a parabola like this. This is f of x equal x squared. Now, to graph the function d of x, we should to graph the original function f of x equal x squared. Then we have to shift the original function 2 units to the left. Why left? Because we have plus 2. Go back to the rules to graph the function y equal f of x plus 2. See, here is plus 2. So we have to shift the graph of y equal f of x to the left, c units. So 2 units, we have here 0. This is 1. This is 2. So the graph should be something like this. This is d of x. Here we have to show what point the vertex here. The vertex here is minus 2. And this point is 0. And here is minus 1. Any question? Any question for this? What I did here and how I can how I graph it? Is it clear? Number 3. This is number 3. Sorry, it's not 4. Is it clear? Number 3, how I graph it? So first of all, you have to write d of x equal the original function. Then you have to put the function the original function f of x equal x squared, or this is equal x to the power 2. Now you have to modify in the original function. Modify mean you have to change something in the original function. You have to substitute, or you have to multiply by number, or like you have to do something. So here I plug inside the function x plus 2 to make it similar to this one. So after I plug the x plus 2, I get f of x plus 2 equal, here instead of x plus 2, everything squared. And this is, if you go back here to the first line, you see this is equal exactly the d of x. So d of x equal f of x plus 2. This is mean you have to graph the original function f of x, then you have to shift the original function 2 units to the left. Okay, now number 4. Who will help me for doing number 4? H of x equal x minus 3 squared. Who will do number 4? Yes, Anta?
Okay, so it's basically like this example. So can you
H
go
of
back?
x,
Oh, h of
yeah,
okay, h of x is equal to
minus 3 squared, I think.
square.
Yes.
Yes.
Okay.
So
How can I graph this one?
based on the first graph, so you're gonna plug the point at -3, and you're gonna move to the right. I mean to the left.
Okay. This is mean you have to move it to the left or to the right.
To the sense it's a negative.
Here
I
we have
think
negative. If
I
you go
think
back to the rules,
to the right.
negative means shift the graph of y equal to the right.
To the right.
You have to shift the origin to the right. Exactly. How many units to the right?
3.
3. Correct. Thank you. So yes, this is correct. But if I want to like show exactly how many units, and I do it like this, I have to write the original function. The original function is f of x equal x squared, and this is the same as x squared like this. Now, instead of x, I'm going to plug this value x minus 3. So f of x minus 3 equal x minus 3 everything square. You see this? Now this one is exact to this one, and this is equal h of x. So this is equal h of x. Now the graph of h of x equal f of x minus 3. This is mean we have to graph the original function f of x equal x squared. This is the original one. Then we have to shift the original one 3 units to the right. because we have minus by using the rules. Minus means we have to shift it right C unit, 3 units here. So so the shifting of the parabola x squared, this is the original 3 units to the right. So it should be something like this here, 1, 2, 3. And here is 3. So the graph will be something like this. So this is f of x, h of x. The blue one is h of x. Any question for the graphs? Okay, if no questions, we're going to use, I'm going to give you example that's combining the right and, combining the horizontal and vertical shifts. So I'm going to combine in the same thing, in the same example, the horizontal and the vertical shifting. Here is the example. For the example, combine horizontal and vertical shifts. Okay, so my example is graph, sketch the graph of f of x equal square root of x plus minus 3, and outside is plus 4. Square root of x minus 3 plus 4. So my question is how we can graph this function. What we should do for graphing this function. First of all, you should to ask yourself, what is the original function? O of x. O of x is the original function. What's the original function? How we can starting graphing this one? What is the original function? What's the function I start graphing? I mean, like original function, what is the basic function I start graphing? Is it O of x equal x squared? No. Is it x cube, for example? Is it x cube? Radical, exactly. So the function, the original function is radical. Why is radical? It's radical because we have a radical inside the example. So my original function is a radical of x. This is the first step you have to know. What is my original function? It's a radical because I have a radical inside the example. Now, I should to change something inside for this example, for this, the original function, to make it something like this. I have to add and substitute and doing something of O of x to make it something like this. First of all, I see x minus 3 inside the radical. Inside the radical here, I see x minus 3. So what I should do, I have to plug instead of x, instead of this x inside the radical, x minus 3. So O of x minus 3 equal the radical of x minus 3. This is the first step. Now I see here 4. The 4 is outside. What I should to do here for the original function? To make it something like this. What I should to do now? I be like close to the f of x. What I should to do? What I have to add for both sides?
4.
What I should, yes, add both side by 4. Add this by 4. Now I'm going to get O of x minus 3 plus 4 equal the radical of x minus 3 plus 4. Now look, this side is exactly to this side, and this side equal f of x. So this is equal f of x. Now I can say f of x equal to this thing. So f of x equal to the O of x minus 3 plus 4. Now to graph this one, we have to graph the original function, square root of x. Then what we should to do when you see the minus inside the parentheses? The minus 3 inside the parentheses, which rule we have to use? One or two or three or four? We have here, I'm going to graph the function, this f of x, by graphing this function. The original function of x minus 3 plus 4. But I see the minus 3 inside the function, the original one. What does that mean? The minus 3 here.
Move to the right 3.
To the right, exactly. This is mean we have to move the original function this way in the radical 3 unit to the right. And what does that mean? Plus 4 outside. Go back to the rule. Outside the parentheses, plus 4.
Then move up 4 units.
Yes, then after we moving to the left 3 units, we have to move 4 units to the up, like this. Exactly, up 4 units. So this is mean here, we have to move the original function, this one. This is my function. We have to move this one 3 units to the right. Then you have to move it 4 units to the up. So to graph these things, here is the graph. So the graph of the original function, the square root of x, this is O of x equals square root of x, is like this, as we learned from last time. Here is O of x equal square root of x. Now we have to graph the function f of x, we have to graph this thing, all this. And all this is mean we have to shift the original function, this one, 3 units to the right. Here is 3 units to the right. 1, 2, 3. This point will be here. And all points will be shifted to the right 3 units. So the graph will be something like this. This is O of x minus 3. Now to graph the function O of x minus 3 plus 4, mean we have to shift the red one, you see the red one, up 4 units. So this is 0, this is 1, 2, 3, 4. So it should be like here. This is the first point, and then you have to graph it like this. This point you have to show me what is this point. This is point here is 3, because here we have 3 is 3 comma 4. 1 2 3. Okay, any question? And here the red one is f of x, or you can say O of x minus 3 plus 4. Any question? Is it clear how we can graph, how we can combining horizontal and vertical shifts? Just you have to do the steps. You have to plug, then you have to add. Here I plug inside the function. First of all, you have to know what is the original function. You have to ask yourself, what is the suitable function I can use it for this? You ask yourself, is it x squared? No, it's not x squared, it's not good. X cube? No, it's not good to use it for this function. Is it, for example, the absolute value of x? No, I did not use any absolute value for this function. Then you ask about the radical for x. Yes, I can use the radical because I have radical here. So I will use the original function as the radical of x. After you write the radical, you try to modify the radical of x as something like this, as something similar to the f of x. So first of all, plug inside the function the value x minus 3. When you plug the x minus 3, you will get O of x minus 3 equal the radical of x minus 3. So it's similar to until this side. Now to get a plus 4, you have to add 4 for both sides. O of x minus 3 plus 4 and the radical of x minus 3 plus 4. Now you get O of x minus 3 plus 4 equal square root of x minus 3 plus 4. And this side, if you go back and you see, it's similar to this exactly. And this is f of x. So this is equal f of x. Now f of x equal the O of x minus 3 plus 4. So this means you have to graph the original function O of x is the black one. Then you have to shift it to 3 units to the right because we have minus 3 inside the parentheses. We shift it to 3 units to the right. Here is the red one. Then you have to shift it 4 units to the up. The red one, you have to shift it 4 units. So here is 1, 2, 3, 4. This is the first point, and all points 4 units to the up. So this is the blue one is the graph of the function f of x. Now reflecting a graph. Reflecting graph. So as before, we have some rules. To graph the reflecting graph, we should use some rules. So the rules are number one, the graph of y equal the minus of f of x, we have to reflect the graph of y equal f of x. This is mean we have to reflect the original function in the x-axis. Why? Because the minus is outside the function f of x. But when I put the minus inside the parentheses or inside the function, this is mean we have to graph the original function y equal f of x. Then I have to reflect it around the y-axis. So if the minus outside, we reflect it around the x-axis. If the minus inside, we have to reflect it around the y-axis. Okay, any question for this? Is it clear what I said here? Let me graph to explain it more what I said. So suppose my function is, for the first graph, is look like this. This function is f of x. And the question is graph the function uh, minus f of x, minus f of x. So graph minus f of x. How I can graph it, this one? How can I graph the minus f of x? So to graph the function minus f of x, you have to graph the original function is f of x, then you have to reflect the original one f of x in the x-axis. So this is the x-axis. Here is my x-axis. So this is my mirror. Here is my mirror. I have a mirror in the x-axis, like this. Now all points will be reflected. So this point, for example, will be here. Okay. This point will be here. This point will be here. This point will be here. And the graph will be something like this. This is the graph of minus f of x. Now to graph the function, suppose I have another function. The function is f of x like this. This is f of x. Now the question is graph the function f of minus x. So the minus is inside the parentheses. You go back here, the graph of y equal minus f of minus x. We have to reflect the graph of y equal f of x around the y-axis. So my mirror is the y-axis like this. So this is my mirror. So the graph will be something like this. Around the mirror, around the y-axis, the graph should be, this is f of minus x. Okay, any question for the both of the graphs? Okay, now let me give you example how we can graph the functions. The function like this. So my example now is sketch the graph of each of the function of the functions. So number one here, f of x equal x minus x squared. You have minus times x squared. Number two, g of x equal square root of minus x. Okay. Who will do the first one? Here, by the way, it's square root of x, here x squared. Who will do the first one? Or tell me the idea how we can graph f of x equal minus x squared. Tell me how I start. I can do a graphing for this one.
First you're gonna graph x squared, which is the original function.
Exactly. So first of all, I should graph the original function is x squared. This is my function, x squared. Perfect. Now, what is the second step? How we can graph the minus x square? What does that mean of minus? The minus is outside the function. If you go back to the rule, the minus is outside the function. You see the minus is outside. But when the minus is inside, so everything will be different. If the minus outside, we have to reflect the original function around the x-axis. So how we can graph the first one, f of x, around which axis we should to reflect it?
X
The
axis.
x-axis.
Around the x-axis, exactly. Because the minus is in outside the function, this is mean we have to graph the function x square around the x-axis. So around the x-axis, my mirror will be here. This is like a piece of mirror, the x-axis, and everything will be reflected. So this point here will be here, the same. For the points here will be like reflected like this. This side will be reflected like this. So this is minus, or this is f of x equal minus x square. So f of x equal minus x square. So to graph the first, yes, exactly like this. So I'm going to show you how we can do this step by step. First of all, you have to write the original function O of x equal x square. Now, what you have to do to get the minus outside the x? What you should to do for O of x to make it similar to this? What we should to do for the original function O of x equal x square to make it something like this, minus x square. Multiply by what? Multiply both sides by what? By -1, exactly. Multiply both sides by -1. Now we get minus O of x equal the minus of x square. And the minus of x square is the same as here. And this is equal to the f of x. This is equal f of x. So actually f of x equal minus O of x. And to graph these things, you have to go back to the rule. To graph the function y equal minus f of x, you have to reflect the original function y equal f of x around the x-axis. So this is mean here, you have to graph the original function, this one. And this is what we did here. We graph the original function x squared. Then you have to reflect this one around the x-axis. You put the mirror here in the x-axis, and all points you have to reflect it. For the second one, g of x equals square root of minus x. Who will do the second one? G of x equal square root of minus x.
The original function
What's
is probably square root of x.
correct? Nice. The original function is the square root of x. This is the first step. Nice. Now, what I have to do to modify these things, the red one, we have to modify the original function to make it similar to this. Similar to this. What we should to do? We need here to make it negative x, and we have to do something for this to make it negative x. What we should to do? Negative x minus 1. If I multiply from outside, like Sandra said, multiply by minus 1 from outside will not work because I will get minus O of x equal minus square root of x, right? And this is not the same as this. The minus is inside. What I should to do? What if you substitute instead of this? You change this inside. You substitute something. What if you substitute minus x inside the function? What are you going to get? O of what? What if you substitute instead of x another value like this? O of what? Minus x, exactly. And O of minus x, you have to plug it inside the original. It's the square root of what? Minus x. Now this square root of x is the same as this. And this, the square root of minus x, equal g of x. So this is equal g of x. So I can say g of x equal the original function of minus x. The minus is inside the function. Mean inside the parentheses. You see the minus? When the minus is inside the parentheses, this is mean we have to graph the original function, this one. Then we have to reflect it around the y-axis. Why? Because the minus is inside the function here. So this is my function, O of x. This is the square root of x. Now we have to reflect the square root of x around the x-axis, around the y-axis. So my mirror should be here. So the graph will be like this. Around the y-axis is supposed to be like this. This is g of x equal square root of minus x. Any question for this example? Any questions for this example? Is it clear? Okay, no questions. What about the other student? No questions. Okay. Now we're going over the vertical stretching and shrinking of a graph. After we know how we can do shifting up and down and left and right, up, down, left and right, and also after we learn how we can do reflection around the x-axis and around the y-axis, now we're going to learn how we can do shrinking and stretching. So first of all, we're going over the vertical stretching and shrinking of graphs. So to graph the function, y equal c times f of x, so it depending in the value of c. First of all, look, the c, it's outside the function f of x, it's not inside. So when c is outside the function, we have like some rules for c. If this c is inside, is like if the value of c is greater than 1, if the value of c, if this c is greater than 1, greater than 1 mean like 2, 3, 4, 5, whatever, any number greater than 1, then we're going to stretch the graph y equal f of x vertically by the factor, by a factor of c. If this c is greater than 1, like 2, 3, 4, 5, so we're going to stretch the graph y equal f of x vertically by the factor of c. But if c is between 0 and 1, if this c is between 0 and 1, okay, so we have to shrink the graph of y equal f of x vertically by factor of c. So depending on the value of c, if this c is greater than 1, we have to stretch the graph of y equal f of x vertically. But if this c is between 0 and 1, like 1/2, 1 over 4, 1 over 5, we have to do shrinking for the graph of y equal f of x vertically by the factor 1 over c here, by 1 over c. 1 over c. Okay, let me do a like small graph. I mean for by c, sorry, by c. Okay, let me do a small like graph how we can factor, how we can do shrinking and stretching for the function f of x. Suppose my function is look like this. This is the black one here. This is my function. This is the function f of x. This function is f of x. Now, to graph the function y equals c times f of x, and this c is greater than 1, so it's gonna be like stretching. To show you how we can stretching for the function, so the stretch for this function is something like this. Up and down, stretching vertically. This is stretching vertically for the function f of x. So this is the graph here. The red one is c f of x, such that this c is greater than 1. Okay. Now, to do this one, the second one, if c is between 0 and 1, for example, 1/2, to graph the function c times f of x, and this c is between 0 and 1, so the graph should be like shrinking, like this. This is shrinking. Again, it depending in the value of c. If c outside, so it will be like vertically, like this. If c is outside, it's supposed to be vertically like this. But if c inside, it will be like horizontally. I'm going to talk about the horizontally after finishing this. What is if that is than 0, like -3? Yeah, if it's -3, it's supposed to be like this, reflecting around. When I see negative outside, what does that mean? -3. What is the negative, first of all? Here I get a question from Abu Bakr. He said, what is about if it's less than 0, like -3? For the negative, this is mean we have to reflect it around the x-axis. And for the 3 number is greater than 1, this is mean we have to do stretching vertically, stretching something like the red one. Or we can do stretching, first of all, stretching vertically like the red one. Then we have to reflect it around the x-axis. We have to put the mirror around the x-axis like this. Then we have to reflect it. Okay, that's why here we focus about the positive numbers. Why we focus about the positive? Because the negative will be reflected. So we don't need it. Is it clear? Now we learn how we can graph the function y equal c of f, c times f of x. The same idea for the horizontal. Let me explain the horizontal, then I'm going to give you example. Horizontal, stretching and shrinking here, horizontal. So to graph the function y equal f of c times x, the c is inside the parentheses, inside the function. When the c, the number inside the function will be like stretching and shrinking horizontally. Now we have some rules for the c. So the rules are similar to this, but not exactly. So first of all, if this c is if this number is between 0 and 1, so we're going to do stretching for the graph. And if this c is greater than 1, we're going to do shrinking for the graph y equal f of x, but not vertically, horizontally, by the factor 1 over c. Okay, let me explain this. Here is the difference when the c is between 0 and 1, like 1/2, for example. We're going to do stretching. But if c here is less than 1, between 0 and 1, we're going to do shrinking vertically. But here, if c between 0 and 1, we're going to do stretching, the opposite of the previous one. Now, let me graph an easy one to show you what we did here. So this is my y-axis, this is my x-axis, and my function look like this. This is f of x, f of x. Now to graph the function, f of c times x, and such that this c is greater than 1, we're doing shrinking because the c is inside, and greater than 1, we have to do shrinking horizontally. Horizontally means something like this. This is mean horizontally. Horizontally mean like this. Like this exactly. Okay. So when c is greater than 1, we're doing shrinking. Shrinking means this point will be the same, remaining the same. So this point will be the same, and the graph will be something like this. Like this. This shrinking horizontally. Like this. This is f of c times x, such that c is greater than 1. And to graph the function, f of c times x, and this c is between 0 and 1, this means we have to do stretching for the function. Stretching means the graph should be something like this. Here is the point fixed. Graph should be like this. This is f of c times x, and here the c is between 0 and 1. Okay, any question for this? Any question? Okay, I'm going to give examples if there is no questions. So the example is using the graph O of x equal I give you the graph in the question is x squared to sketch each of the functions below. So first one, A, g of x equal 3x squared. Second one is here number 1. Number 2, h of x equal 1 over 3 x squared. And for d of x equal, open parentheses, 2x squared. Okay, let me fix it. Here we have O of x equal x squared, 3x squared. Here h of x equal 1 over 3 times x squared. And here we have 2 times x squared. Okay, who will do the first one, second one, third one? Who will do the first one? Give me the idea how we can graph this one. Tell me what is the original, how we can do for the original is shrinking, stretching. Yes, the original function is O of x equal x squared. Now what we should to do? What does this mean?
So
3 multiplied by x squared.
so you can multiply 3 by each side. Is that what it means?
3. This, yes, exactly. So O of x equal x squared. We have to multiply 3 to the both side. So multiply by 3, multiply by 3. So 3O of x, 3O of x equal 3x squared. Okay. So this is mean this is equal g of x. Now g of x equal 3 times the original function of x. Now how we can graph this one? Here multiply the 3 outside, and how we can graph the function g of x? G of x equal 3 times the original function O of x. Go ahead.
Now you just plug in x
Is
squared for O of x, right?
when you see the 3 outside, can you tell me what's that exactly? Is it horizontally or vertically? This is the first step. The 3 outside. You see the 3 below?
Yeah.
When you see the 3 outside the function, look here, outside. What does that mean? Vertically or horizontally? The 3 is outside the function. This
Vertically.
is mean what? Exactly. So this is the first step. You have to say the 3 is outside, like this, outside. So it is vertically. It is vertically. Vertically mean up, down, like this. Now, you ask yourself, is the 3 greater than 1 or is between 0 and 1? Is the 3 is greater than 1 or is less than 1? I mean, like between 0 and 1. Greater than 1, correct. So it's greater than 1. Perfect. So you have to go back to the rules. Outside is vertically and greater than 1. So this is mean we have to do a stretch. You have to do a stretch of the function y equal f of x or of the original function. A stretch mean look to the red one, look to the red one, become like goes up. Stretch mean goes up of the x-axis. Look to the red one here, goes down of the x-axis in the negative 1. So can you go back to the graph? Which graph? This one, Jonathan? Okay, no problem. So the 1 is greater than, the 3 is greater than 1. So this is mean stretch. So you have to know it's outside. This is mean vertically. This is number 1. Very important. Put 2 line. And 3 greater than 1 means stretch. Okay. So I get vertically and stretching. So to graph this function, you have to graph the original one. Here is the original function. Is O of x equal x squared, parabola. It is a parabola like this. Okay. Now, how can I graph the stretch? Stretch mean we have to make it like, and stretch vertically is supposed to be like this. Look, the graph. So vertically, something like this, or like this, like this, or like this. Because stretching mean we have to make it far off the x-axis. So the graph will be something like this. Far from x-axis. This is g of x. And the black is the original function O of x. So this is the graph of the function g of x. You have to ask yourself, the 3 is outside, and also in the same time, the 3 is greater than 1. This is the very important. Outside means vertically, greater than 1 stretch. Then you graph it. For the second one, the second one, h of x equal 1 over 3 times O of x.
I think first you're supposed to multiply by 1 over 3 on both sides.
Yes, exactly. So the original function is O of x equal, here number 2, equal x squared. So you multiply both sides by 1 over 3. Multiply this by 1 over 3. I get 1 over 3 O of x equal 1 over 3 x squared. And this is exactly the same as this, h of x. And this is equal h of x. So h of x, this one, equal 1 over 3 times O of x. So to graph this function, what we should do now, I simplify it for you. So h of x equal 1 over 3 times O of x. How I can graph now the function h of x? You have to ask yourself 2 questions. Is the 1 over 3 outside the function? And what is the value for 1 over 3? Is it greater than 1 or between 0 and 1? Two questions. Is it outside the function? It's between 0 and 1. This is correct. 1 over 3 is between 0 and 1. Okay, perfect. Now, is the 1 over 3 outside the function? Is it outside or is inside? I mean, inside inside the parentheses.
It's
Is it
outside.
inside the parentheses? Outside. So 1 over 3 is outside. Outside mean it is vertically. We have to do shrinking and stretching vertically. This is mean vertically. Vertical. So vertically, and the number is between 0 and 1. Go back to the rules. Here is the rule. This is for the vertical. And the number is between 0 and 1. This one. This is mean we have to do shrinking for the graph for the original function vertically. Shrinking mean, look to the blue one, is it close to the x-axis? We push the black one down. The black one is f of x, we have to push it down, the blue one. And the same things for this side, we push it down like this. We push this one down. This is mean shrinking vertically. So my original function, let me grab the original function is O of x equal x squared. This is the function f of x equal x squared. Okay, so because outside vertically and 1/3 means shrinking, shrinking, this is mean we have to make it close to the x-axis like this. Shrinking mean like it close to the x-axis, and because it's vertically like this. This is the function h of x. Any question? Any question for this? Can you explain the one again? Okay. Yes, sure. I can explain it. So the function is the original function O of x equal x squared. And the function I need to graph is h of x equal 1/3 x squared. Now I have to modify for this function. I have to multiply or substitute anything to make it close to this one, 1/3 x squared. So the best things to make it close to this one, we have to multiply both sides by 1/3. When I multiply 1/3 to both sides, I get 1/3 O of x equal 1/3 x squared. And this is 1/3 x squared is the same as h of x. So I make it equal h of x. Now h of x equal to 1/3 O of x. This is what I write it here. Now, to graph the function h of x equal 1/3 times O of x, the original function is x squared, the parabola. You have to ask yourself two questions. The first one is the 1/3 outside the function or inside the function? I mean, for outside, is it inside the parentheses or outside the parentheses? So as I see here, 1/3 is outside the parentheses of the function O of x. So 1/3 outside. This is mean if it's outside vertically, vertical. Is not horizontal. The horizontal inside, but the vertical outside, the C outside the function. And you have to ask yourself another question. Is the 1/3 greater than 1 or between 0 and 1? So 1/3 is between 0 and 1. It is a small number. So if it's 1/3 between 0 and 1 and vertically, you have to go to the rule here. If C between 0 and 1, we have to do shrinking for the graph of y equal f of x vertically. Vertically shrinking means we have to push the function down close to the x-axis. Okay. So my original function is the black one, parabola. Now I have to push the original function to the close to the x-axis. When I push the function from this side, it will be like this, and from this side will be like this, and to the 0 will be like the same 0. So the graph of the function is the blue one, this one, and that's it. You're welcome. So for the now for the third one, d of x equal 2 times x, everything square. Number 3, the function asks me to graph d of x equal 2 times x, everything square. Now, first of all, how can my original function of x equal x squared? This is my original function. How I can modify this to get something like this, 2x to everything square? And again, this is equal x to the power 2. What I should do? What I have to substitute? The best things here, when you see the value under the root, the power, the exponent, is the best things to substitute. What you should to substitute instead of x? Only 2 or 2x? 2 or 2x together? The best things, you have to substitute 2x inside this function. The both of them, 2x inside the function. Now, when you substitute 2x inside the function, you will get 2x to the power 2. Now, this value here is the same as this value, and this is equal d of x. Now, d of x is the same as O of 2x. Now, how we can graph the function d of x? Is the 2 inside or outside the function? Is the 2 here, number
Inside.
2? Exactly. So the 2 is inside the function. The function O of x, O of 2x. So inside mean, look, inside mean horizontal. See the horizontal? Horizontal because inside. So here I can say horizontal or horizontally. Now my second question, is the 2 between 0 and 1 or greater than 1? Is this 2 greater than 1 or between 0 and 1? Greater than 1. So the 2 exactly greater than 1. So which rule this is mean greater than 1? Greater than 1, we have to do shrinking. Shrink. Exactly. No, shrinking. If c greater than 1 and horizontal, see the horizontal, mean we have to do shrinking. Horizontal and greater than 1. Because why horizontal? Because the c inside the parentheses. Here the c, the 2 is inside the parentheses. So 2 greater than 1, this is mean shrinking. Okay, so we have horizontal and shrinking. First of all, we have to graph the function. This is the function, the parabola function. Not good. Okay. This is d of x. D of x. Now my question is, we have to graph the function. This is not d of x, sorry. This is O of x equal x squared. Now to graph the d of x, we should to do a horizontal shrinking for this one. Horizontal mean something like this. This is mean horizontal. Like this or this on this side, this or this. Okay, horizontally shrinking, it will be like close to the y-axis. Close to the y-axis. Horizontally mean like this or like this, and shrinking mean close to the x-axis, the y-axis. So it will be like this. So this is d of x. The red one is d of x equal to x everything square. Now, any question for this one? Any question for this example? Okay, if no questions, we're going to stop up to here today, and next week we're going to continue. Have a good day, everyone. See you next week.